Are you a data scientist? Do your tools make it easy to track your experiments, deploy to a machine learning model to production, and manage a GPU cluster? This free book from O'Reilly can teach you how to do all that. It's about tuning neural nets, making them scale, and then deploying them to the real world.
Hello girls and guys, and welcome to an in-depth machine learning tutorial series. The objective of this tutorial series is to give you a holistic understanding of machine learning and how it works. And we're going to be doing this by covering a variety of algorithms. So first we're going to be covering regression, then we're going to be moving into classification with k-nearest neighbors and support vector machines, and then we're going to get into clustering with flat clustering and hierarchical clustering, and then finally we'll be getting into deep learning with neural networks. So at each step of the way with each of the major algorithms, we're going to cover theory, application, and then we're going to dive in deep to the inner workings of each of them. So with theory, this is just the high-level intuitions. It's actually pretty quick to digest the theory of all the algorithms. Most of the algorithms are actually fairly basic since they need to be able to scale to very large amounts of data. Then we move on to application. This is also fairly quick. We're going to use a module like scikit-learn and apply these algorithms to real-world data to see exactly how they work, what kind of input they expect from us, and what kind of output we should expect back from them. Then finally, we dive into the inner workings, and the way that we're going to do this is by recreating the algorithms themselves from scratch in code, including all of the math and all of that. So when you do this, you'll be able to have a truly complete understanding of how these algorithms work, which is going to help you down the line. So in order to follow along with the series, I strongly suggest you at least have the basics of Python 3 down and understood. If you don't, I do have a Python 3 basics tutorial series here. Check that out. You really just need to get at least to the point where we install modules with pip. After that, you can continue on, but you really need that initial, I think it's like maybe 10 to 15 videos of core understanding of Python. We'll also be covering a healthy amount of math here, but we'll be talking about the math and explaining that as we go for sure. So you're not really expected to know much about math. It's going to be mostly algebra and geometry that comes up. So machine learning really came about in the 50s, so like more than a half century ago now. And it was defined in 1959 by Arthur Samuel as the field of study where we give machines the ability to learn without being explicitly programmed to do so. So the way I kind of like to think of it is it's imbuing knowledge to a machine without hard coding that knowledge. So interestingly enough, when I talk to people, both programmers and non-programmers, and find out what they know about machine learning, most people think machine learning is hard-coded. So when you ask them what's wrong with machine learning or how is it different from actual learning, that's where you find that most people think it's hard-coded. So kind of interesting issue there that most people are completely unaware that this field exists and it's actually not being hard-coded. So that was when machine learning was actually kind of defined. In 1963, Vladimir Vapnik came up with the support vector machine, but this really went pretty much overlooked until the 90s. So Vladimir Vapnik was in the Soviet Union, and then in the 90s, he was actually scooped out of the Soviet Union by Bell Labs. And that's when he showed that, that the support vector machine was better than the neural network at the time, doing handwritten character recognition. So it was handwritten digits, if I recall right. But anyway, it was better than the support vector, or better than the neural network at that task. Then support vector machines really took the lead for quite some time, really up until very recently, when Google basically has kind of come back to really put some weight behind the neural network, specifically with deep learning. But if you think you're kind of late to the party, so to speak, with machine learning, I assure you you're not, because, I mean, think about computers in the 1950s. I mean, we're talking, we just started putting transistors on printed circuits. Instructions to your computer was maximum a handful of bits at a time, so pretty bad. I mean, even think about your computers in the 90s. It was very hard, even if you were like a PhD student, it's very difficult to even get access to a machine that could run significantly, a support vector machine at scale, let's say. Whereas nowadays we live in a time where you can engage in deep learning with neural networks on like gigabytes or even terabytes of data. And what you can do is you can spin up a $100,000 GPU cluster on Amazon Web Services and basically just rent it for a few dollars an hour and then be done with it. That's incredible. Like, we live at an incredible time. This is the best time to be alive, is, I think, right now. This is the first time we've really been able to really stretch and flex the muscles of machine learning. Up to this point, it's really been learning without the machine part. So we're also so much to the point where, like, with scikit-learn, you can use scikit-learn with almost no understanding at all. You just apply it, and you can usually get about 90 to 95% accuracy without messing with the default, you can just get it with the default parameters. So that's also pretty crazy, right? If you want to push the limits and get more accuracy out of it, then you need to learn how they work and how you can tweak those parameters. So if you're working on a self-driving car, getting 90 to 95% accuracy and identifying the difference between, like, a blob of tar and a child in a blanket, that's not good enough. You need more accuracy than that. So anyway, that's who this series is for the people that are really looking to push the limits on what's available. So if you really just want to learn the basics, I actually already have some simple machine learning tutorials out there for just applying machine learning to a data set. You can do this actually very, very fast. So anyways, the first topic that we're going to be covering is regression, and let's go ahead and get into it.